So let's find the surface area of a cone that has height h and base radius r. So I've drawn the cone kind of upside down just to make the formulas easier. Although once I had a student who pointed out that if you're holding a cone in your hand, this is how you would hold it. So maybe this should be right side up instead of considered right side up instead of upside down. Okay, so here's our picture of the cone. So this is this is the height h. So first we need to write down a parameterization of this cone. So we'll use an angle theta for the circular position. So theta goes between 0 and 2 pi. So x will be something times cos theta, and y will be something times sine theta. And then our z, we'll take our z, our second parameter, to just be the height. So z goes between 0 and the height h. So now we just need to figure out what is the radius that we put here. So that's like, what is the radius here? Well, this height here is z. And so by similar triangles, the height we should put in here is r over h times z and r over h times z. Okay, so this is our parameterization. Now, now we need to find the surface area differential. So let me write C of, I'll call this C of theta z instead of r, just to avoid confusion with like the radius r. So C theta cross CZ is going to be, okay, so the differential of this with respect to theta is negative r over hz sine theta, r over hz cos theta, and 0, and then the differential with respect to z is r over h cos theta, r over h sine theta 1. So we have I, j, and k. So that determinant will be let's see, so we can pull out this r over hz. So this will be rz over h times, so this will be cos theta I, and with j we do plus sine theta j, and with k we get r over h, so sine squared theta and cos squared theta, but this has a minus, so minus r over h. K is this cross product normal vector. And now, okay, so the magnitude of that is c theta cross cz. Magnitude is rz over h, and then what's the magnitude of this? That'll be root 1, because cos squared theta plus sine squared theta, plus r squared over h squared. And then we can write this as all h squared plus r squared over h squared, and pull the h squared out of the square root. So this becomes rz over h squared root h squared plus r squared. So now we just need to integrate that. Okay, so if we integrate, so surface area is integral c theta cross cz d theta dz for r. So that's z is going from 0 to h, theta is going from 0 to 2 pi, rz over h squared root h squared plus r squared d theta dz. Now r and h are constants with respect to both theta and z, so we can already pull out r over h squared root h squared plus r squared. And also theta integrating from 0 to 2 pi will just contribute to 2 pi. So we get 2 pi r over h squared root h squared plus r squared integral 0 to h z dz. And so this will be h squared over 2, so that cancels this and also this. So the surface area is pi r root h squared plus r squared. Let me make a warning. This is only the surface area of the sides of the cone. If you wanted to also include the base of the cone in the surface area calculation, then we would also add a plus pi r squared is the area of the base of the cone.